going on, everybody? What's going on, everyone? Come on in. Come on in. What's going on, everyone? Come on in. Come on in, everyone. Let me just give it a few minutes to give a few more people a chance to come in. Today is going to be a very interesting day. Hopefully, I'm streaming into the unit today. So thank God if I'm able to get a chance to have my patients see me now. I mean, this is really an accomplishment for us. We work very hard for this. I want to be able to bring my patients more information about their treatment. And so every day at noon, I'll be teaching the medical students and other students. And so of course, we have the student program here. And I think I can use this as the streaming as an opportunity to um, start to teach the medical students and the other students more about the disease processes and have the patients listen in on it. So this discussion now is more oriented towards the medical students and it's from the medical perspective. And so we're going to talk about the molecules, the receptors, the pathways, the things like that, the molecular biology underneath the science. And as a patient, you get a chance to listen to this, you know, and what happens at the molecular level is amazing, that's why you see me very interested in these things. And so for the first time, I get a chance to really get a chance to verbalize what it's like internally, what it's like to do this type of work. Psychiatry is very complicated because everything is what you're interpreting and how you're reading things and stuff. And so we're just trying to do a better job, So if my patients can hear this, hey, we've gotten a victory today because I'm going to be bringing you more of the medical education this way. And also, you can go to my YouTube site podcast, Read Matrix. The matrix is your ego. And the ego is the structure that basically contains your consciousness and interprets everything for you. So my goal is to sort of help people deal with their mental health issues by learning to manage your ego and also how to escape your ego. So it'd be interesting to talk about many of those things. So the subject is primarily directed towards the students. But if my patients have any questions, I believe I set up a way so that you should be able to ask questions. If not, then hopefully I'll have it set up next time. But I do want my patients to be able to ask any questions you want. And I'm doing this for you. I want to be able to give you more information and to empower you as much as possible. Another thing, I'll be opening up in the process of opening up a walk-in clinic on the first floor at Jackson Park on the Stony Island side. So hopefully I can get it running between 8 in the morning to 8 in the afternoon, 7 days a week. So we're in the process of working on that. So hopefully that way, if you need me or contact at all, you can just come to the hospital in a walk-in clinic and be able to gain access to me right there to get refills or whatever you need from there. And also, I should be able to do direct admits from that point also. So I can get you medically cleared and things like that in my outpatient clinic, and then simply have you schedule a time to go through the emergency department, schedule a time to enter the emergency department, be evaluated, and then enter the unit. We're also, later this month, we're going to open up an online clinic. And so I'm going to have all my patients register online so they can be getting direct contact with me. So hopefully you can just one button and I pop up on the screen, something like that. I'm trying to continue to eliminate the barriers between me and my patients, and so you can always get in direct contact with me. And you have my number anyway, 708-873-9059. If you're my patient, please feel free to call me at any time. And so the online clinic is going to be a innovation in this space, because we're going to be doing the focusing on medical clearance from the online platform. And so you should be able to get all of your evaluations. If it's not an emergency issue where you need to go into your emergency department, you should get all your evaluations and assessment online, and then I can help you get to the hospital you want to go to. So that our online clinic is going to be coming online soon. And if you would like to practice with me here at this hospital, I'd love to receive you. If there's any psychiatrist or medical doctor that's interested in practicing with me here, I would love to receive you. I think we have a very good program on Leapfrog. I think we got an A rating on Leapfrog, and I think we worked very hard for that. And we're safety net hospital with an A rating. So it shows that, with very hard work and determination, that we can provide the same level of care as the big boys, doing it at a safety net hospital. And it makes it very good. So I'm looking forward to a lot of these changes. Okay. So 6 minutes. Okay. So let me go ahead and get into this. I began a series on networks, describing networks. The first network I described was the mesocortical pathway. The second was the mesolimbic pathway. Now, this structure we're about to talk about now is called the basal ganglia. The basal ganglia is a cluster of nuclei, of subthalamic nuclei. And one of the primary roles it plays is responsible for movement, so motor movement. And so when we have difficulty or damage to the basal ganglia or its functioning, it results in movement disorders or movement problems. The basal ganglia is a highly dopaminergic neuron system. Death of the dopaminergic neurons actually lead to the dysfunction. So I have one of my idols, Muhammad Ali, and I'm sure you know about him. He was a famous boxer, and he developed Parkinson's disease, right? Seeing as a child, seeing how magnificent this man was, it's absolutely amazing. How much of a strong personality he was, it was sad to see him at an early age, around 30, start to develop symptoms of dementia. And it got, his Parkinson's dementia got pretty bad. So I'm going to try to link the functioning of the basal ganglia to, for the students, I'm going to try to link the functioning of the basal ganglia to Muhammad Ali. So hopefully I help you remember this content. Okay, so here, I looked up here on this AI search engine. Okay, how many punches to the head do you estimate Muhammad Ali received during his professional career? How many punches to the head? 29,000? 29,000 punches to the head. Punching people in the head leads to inflammation. And the inflammation isn't good. The problem with inflammation is it causes the blood-brain barrier to become porous. When the blood-brain barrier becomes porous, then all the content in the serum enters the cerebrospinal fluid. Now the machinery doesn't work at all. So if the nerve fibers cannot operate because there's debris in its field and things like that, then it presents like glitches and things like that. So it presents with confusion and disorientations, altered mental status, diminished and SORM, lack of awareness of environments, things like that. So can you imagine 29,000 punches? And this is someone who's trying to hit you as hard as they can. There's somebody hitting you at the full. These are strong men. hitting your brain, um, hitting your brain. Um, and so those are different type of punches. It's like those are not everyday punches. And so you can imagine the recurring bouts of inflammation and then the accumulated injuries that would occur over time. The basal ganglia is located deep within the structure of the brain. So if I can give you, let's see, okay. So here's Wikipedia, here's the brain here, and it's this collection of subthalamic nuclei. And look where it's positioned. Right here's like the stalk, and it's here in the deep structures of the brain. Um, Let me see if I can show you the inner surface of a skull. Let me see if I can. Okay, yeah, here. Okay, so here's I don't know if it's going to open up, but what I'm trying to show here, here's this bony region here, and there's not much room. The structures here are cavernous, and they're bony structures that are unforgiving. So when someone punches you in the head as hard as they can, your brain is like the sponge. And the damage can occur at the stalk, significant damage at the stalk where the basal ganglia is at, and the subnuclei of the basal ganglia is located at. And so 29,000 times. And if you can imagine the reoccurring bouts of inflammation and things like that. And so I in my opinion, um, the mechanism of injury for his basal ganglia was likely due to traumatic brain injury. Repeated inflammation, damages to the brain, repeated inflammation to the basal ganglia area, to those and to the point where those nerve fibers they began to die. And when those nerve fibers began to die, he couldn't move his muscles, and so he's like frozen. And so let me see if I can sort of give you an idea of how some of it looks here. Here's just the video, and do you see like the mass facies now? Yeah, you see the mass facies. Yeah, those cranial nerves are still innervated, controlled by the basal ganglia at that point. And if you have a death of dopaminergic neurons, then you have the loss of the decreased production of dopamine from the presynaptic receptors that are no longer there. And if you get decreased production of dopamine, then the entire dopaminergic network is hypoactive, and therefore the movements are hypoactive. And we describe this as a psychomotor slowing or as a psychomotor retardation or something like that. So you can see here how the champ is, he's gone through some brain changes. And let me see here. Let me see if I can answer any questions at this point. Okay, great. Okay, Dylan, you have some pretty good questions. They're so in depth. I don't think I know the answers to those in depth questions. Let me see here. Okay, let's see here. Okay, let's see here. Hey, iHash, thanks for the question. What treatment approaches are available today that Ali did not have access to? Newer generation of medications that are more specific for targeting the networks. Newer medications. I don't want to go through those now. I don't want to get the students all mixed up. Okay, great. Felipe Furlan. Felipe Furlan, all the way from Brazil, little small town called Rio Claro, huh? Can I think of instead? Can I? Okay, right. And so it's hard for Felipe is saying he's a developer. It's hard for him to think about 29,000 punches over a certain period of time. He think of it in terms of a flow, a punching rate. Awful. You're awful. Thanks for the question, Felipe. Hope I answered it. 29,000 punches from a professional boxer career are heavy to take. I don't even find that attractive as entertainment, And, the thought of hitting someone and damaging their brain to win a game, it's too much for me. Next question. Can Parkinson's show up years after the damage began? Absolutely. Absolutely. It's thought that the Parkinson's is sort of the brains, the cells are die because of the buildup of, I think, tau power products or something like that, intra-inclusion bodies that build up to the point where it pops the cell wall and the cell die. So you have the buildup of debris inside of those cells in the area of the basal ganglia that actually result in the death of the brain cells. And we'll go through that mechanism a little bit later to show you how it does it. And then I think for here's with the champ here's inflammation, repeated about for inflammation. Now, when those brain cells die, they don't come back. And so I wonder if the area is insecure, meaning I think the blood-bearing barrier in the areas where you have damage may be, I don't know, I'm not sure if the blood-brain barrier can be repaired in those areas. So I think that you're going to constantly deal with altered mental status and mental status changes secondary to the inflammation. Okay. Can Parkinson's show up years after damage again? Yep. Okay. Next, Muhammad. Is Parkinson's always caused by trauma, or can it happen without head injuries? The mechanism for Parkinson's is basic, is the buildup of the inclusion bodies that result in the cell death. But in this case with Muhammad Ali, I'm thinking that inflammation played a role in it also. And the reason why is that he had other types of behavioral and other types of problems. Besides just movement. Okay. Did Ali's intense medical discipline slow down the progression of the disease? I would think the hyperdopaminergic state of a boxer would probably be too much for his hippocampus and the parts of his brain. So I think being in that state isn't good, that the hyperadrenergic state isn't good. And I think that being in that fight or flight modality causes damage to certain vulnerable area, particularly the hippocampus. That's why victims of chronic stress and abuse usually have memory and then begin to develop cognitive problems as a result of that. So I think that there's a vulnerability being in a fight of your life, and then they're in situations where they get knocked unconscious. I mean, who goes to work and get knocked unconscious and then get up and then just shake it off? That whole fight or flight state is just not good. It's not good. Okay. And so I think that all of these were vulnerabilities set up from the start. Okay. Here, let's go ahead and look at the receptors on the basal ganglia. So after you sort of understand the receptors that are located on the basal ganglia and how they operate, then you sort of begin to understand exactly what medications to use to treat these disorders, right? And so the issue is the death of dopamine neurons in the basal ganglia, specifically in the area of substantia nigra. You can see it on autopsy when you look at it under methylene blue stains. So it's the loss of dopamine, and it's dopamine hypoactivity, and this leads to the hypoactive network. So we need to do everything we can to increase dopamine, right? So the enzyme that um, degrades dopamine, we need to turn that enzyme off, right? The enzyme that takes the dopamine and from the presynaptic cell that re-upstate the dopamine from the synaptic cleft into the presynaptic cell, we need to turn that pump off. You know, and so that's basically the strategy um, here. Okay, so the receptor profiles in the basal ganglia. Receptor profiles in the basal ganglia. Okay, the basal ganglia contains a diverse array of neurotransmitter receptors, including, remember, dopamine, right? Okay, GABA. Remember, GABA is the main inhibitory present in all cells. Look, fortunately, we have that GABA there. Glutamate, remember, the excitatory neurotransmitter. Glutamate. Of course, remember all the hyperactivity and agitation, combative aggressiveness, right? And remember, we give benzodiazepines, Ativan, IM, to activate glutamate to sort of reduce the psychomotor agitation, combativeness, and aggressiveness. Remember, we do that. And so here's that story: GABA to relax, glutamate excitation, and then look here, acetylcholine. Okay, and with patients with a cognitive deficit and dementias, even with agitation things, we also use Aricept to help with that. Um, Okay, so here, of course, we have the dopamine 1 and 2 receptors. Here are GABA receptors, okay, chloride channel, glutamate receptors. All right, okay, here's the acetylcholine receptors, and these, have additional receptors. Okay, and so, um, okay, so let's see. Okay, okay, here's another question here. Hi, Umber. Okay, are there any treatments in the works to protect dopamine neurons in high risk people like boxers? I don't think I don't think that's how they go about developing pharmaceuticals. You know, avoidance would be the solution. Avoidance would be the solution. Okay, let me move to the next question, next issue. Okay. Okay, here, let me just review Parkinson's dementia real quick. I just went on Wikipedia just to get some general stuff. Here, Parkinson's disease dementia is a dementia associated with Parkinson's disease. That sounds circular to me. Together with dementia with Lewy bodies, it is one of the Lewy body dementias characterized by abnormal deposit of Lewy bodies in the brain. Okay, let me see the Lewy bodies. These are the inclusion bodies I was describing. Lewy bodies are inclusion bodies, abnormal aggregates of proteins that develop inside the neuron affected by Parkinson's disease. The Lewy body in the Lewy body dementias and in several other disorders such as multiple system atrophy. All right, going off to other subject. So here are the inclusion bodies that build up inside. It's like the debris that builds up inside of the neuron, and I think it like piles up to the point where it can actually disrupt the membrane, the cell wall, because of them. Now, these you pick these Lewy bodies up on now. The Lewy bodies are also present throughout other cells within and other parts and tissues within the brain. So simply because the Lewy bodies are present in a cell, that doesn't mean that it's going to have that detrimental effect of destroying the cell. So they're not sure. So when you look at how widely Lewy bodies are spread throughout the body, it's not sure exactly why some areas, particularly basal ganglia, degrade sooner. So it's not really clear why it's vulnerable to the basal ganglia. Basal ganglia is vulnerable to these inclusion bodies. Here, okay, the defining proteus component of Lewy bodies, the alpha. Alpha forms the aggregate. Okay, so they're shown. Okay, Lewy bodies appear as spherical masses in the neuronal cytoplasm that can displace other cellular components such as the nucleus and neuromelanin. So yeah, this is what I was describing, is that this is like the debris in the, if you think about the neuron as a molecular factory, then this is all the debris sort of piled up, and it can get so large that I didn't know it could actually displace the nucleus. I didn't know the pile got that big. As you can see, it can sort of rupture the wall. Um, a given neuron may contain one or more Lewy bodies. Okay, so I can see how you can see how that can destroy these cells. Okay, let me see here. Okay. So the if the Lewy bodies are destroying the dopamine producing cells, then that means that there's going to be less dopamine produced. And so the overall network is going to be hypoactive, which means the person is going to have psychomotor slowing and retardation, and they're not going to be able to move as much, right? Won't be as spontaneous. And so the goal is to increase the amount of dopamine. So we have to stop the dopamine from being broken down. We have to stop the dopamine from being retaken back up into the cell. And I think we have to also try to produce more dopamine. So carbidopa levodopa is a medication that's very helpful. And here it is. And let me just explain how this medication combo works. Very interesting. It's a lot we'll go through to try to get the drug to that target. Carbidopa levodopa is a combination medication used to treat Parkinson's disease. Its effectiveness relies on separate mechanismal actions of its two components. And this is very interesting stuff. Okay, so here's levodopa's role in dopamine synthesis. Here's carbidopa's role in optimizing levodopa's delivery. Okay. Dopamine deficiency in Parkinson's. Parkinson's disease is primarily caused by a depletion of dopamine in the brain. Right. That's what we said. Levodopa crosses the blood-brain barrier. Levodopa L-dopa is a precursor to dopamine that can cross the blood-brain barrier, unlike dopamine itself. And you see why I put my patients on those multivitamins and things like that. So I want to make sure they have all the precursors to it. Sometimes they may be malnutrition to the extent where they don't have precursors. Okay, next, conversion of dopamine. Okay, once inside the brain, levodopa is converted to dopamine by the enzyme aromatic LAAD. Okay. Okay. Also, dopa decarboxylase. I recognize this dopa decarboxylase. Replenishing dopamine stores. That is when the neuron, when the brain, the cell body starts to produce more of it. This conversion replenishes the depletion of the dopamine stores in the brain, helping alleviate the Parkinsonian tremors. Okay. All right, and so here's the levodopa component. Let's look at the carbidopa's component. Carbidopa's role in optimizing the delivery of levodopa. Again, preventing peripheral breakdown. When levodopa is administered alone, a significant portion of it is converted to dopamine in the periphery. That is outside of the brain, but you want dopamine in the brain, outside of the blood-brain barrier. You creating dopamine outside of the blood-brain barrier, outside of the brain, before it can reach the brain. This peripheral conversion of L-dopa leads to side effects and reduces the amount available to the brain. Okay. Right. So carbidopa inhibits the enzyme in the periphery. Carbidopa inhibits the enzyme dopa decarboxylate in the periphery, preventing the premature breakdown of levodopa outside of the central nervous system. And more levodopa reaches the brain. By preventing peripheral conversion, carbidopa ensures that a high percentage of the administered levodopa reaches the brain, and the brain can be converted to dopamine. Okay, we got that. Okay, great. So the inclusion bodies build up to the point where they can destroy the cell. Fewer cells, fewer dopamine, and so we have to use the tool to increase the amount of dopamine in the interest and amount of dopamine in the synaptic cleft. Okay, let's see. And I think okay, yeah. Let me look at dopamine. This is the production increasing the amount of dopamine. Let's look at dopamine metabolism real quick. And then I think I should take some more questions for you right there. Okay. Dopamine metabolism in the synapse is primarily involved is reuptake into the presynaptic membrane, like we said that, neuron, okay, or degradation by MAO and COMAT. That's it. There they are right there. So those are the two enzymes that can break down and metabolize carbidopa, levodopa, dopamine. Okay, so if that's it, okay, I don't want to go too long. It's 31 minutes so far. I don't want to go too long. Okay, so if does anyone else have any questions at all? Just let me know. Let's see here. Okay, here. Hey, John, thank you so much. Can Parkinson's show up years after brain damage? I would say yes. Is Parkinson always caused by trauma, or can it be caused by head injury? So Parkinson's is caused by the buildup of the intra-inclusion bodies that end up killing the cell and results in a decreased production of dopamine that makes the entire dopamine network hypoactive, and therefore makes the person very slow moving and immobile. So that's the mechanism of Parkinson's based upon the intracellular inclusion bodies. But trauma creates damage and inflammation, and through, just like with Muhammad Ali, I believe there may have been a combination of both. There may have been the trauma with the presence of the intracellular bodies in that area that all came together that created so much inflammation that his basal ganglia and those parts started to die off, and he started to get the symptoms. So the trauma would be a traumatic brain injury, creating the damage that way. So that would be a different diagnosis. It would be a traumatic brain injury, not Alzheimer's. But the symptoms are not Parkinson's, but if it were a traumatic brain injury with the movement part, then it's Parkinsonian-like symptoms, but it's caused by traumatic brain injury. Okay, next question here. Thank you, T-Jam. Did Ali's intense mental slow down progression? I think it did. Umber. Okay, I think that's really. I think I'm going through the same questions. Okay, so so that's it on my presentation on the basal ganglia. I hope it's helpful for everyone. Otherwise, I'll see you guys tomorrow. And for my patients, I hope you guys saw this. If you did, I hope this is very helpful for you. If you have, go to my podcast, Read Matrix, and you can get the link to these. I'm going to start sending you guys the link to these videos, and I'm going to try to use this format to give you as much information as I can and make it accessible to you. So it's a pleasure talking to everyone. Thank you so much, and I'll talk to you guys later. Take care, guys. Read out.